Hello, everybody. I hope you can hear me well. Um, Good morning from sunny and windy Stockholm, and welcome to DB Power Knowledge-based webinars. And today we are going to present you transformer demagnetization, importance of transformer demagnetization, and all the issues you could experience if you forget to perform demagnetization of your transformer. My name is Edis Sosenbasic, and I'm involved in the power transformer testing and developing the testing methods for the transformer, for the power transformers. So if we want to demagnetize transformer or something, we need to have a magnetized condition of something, right? So the first step or first thing we need to understand is what does it mean magnetization of the ferromagnetic material. As you know, in power transformer, we have different parts. There is magnetic core, there is windings, oil, tank, and the stuff there. And all those transformation process, energy transformation process, will happen through the magnetic core of the transformer. So this core needs to be made through ferromagnetic material. And what does it mean, ferromagnetic material? It means that that material is not a real magnet, but in some condition, it can become magnet. Let me. So basically, in one magnetic material, we have magnetic dipoles, which you can imagine like vectors there. And if transformer or core is demagnetized, that means that those magnetic dipoles or vectors inside magnetic dipoles are chaotically oriented. And if we sum all those vectors, we will get 0, which means basically that that core is demagnetized. However, if we perform external force, for example, DC current, we will turn those dipoles in one direction, in direction of the current, and basically all magnetic dipoles, all vectors will be oriented in one direction, creating what? Magnet with the poles. You have north and south poles, because now you have perfectly oriented dipoles in one direction. However, our transformer cannot, let's say, will not operate properly if we have a magnet inside of the transformer, inside the core. So basically, we can expect some effects, some reaction from the transformer. So basically, when transformer is magnetized, when all those dipoles are oriented in one direction, we will see some effects from the transformer. The first one that you will experience if you are working in the substation or if you are working as a testing commissioning engineer, the first effect is high amplitude of inrush current when you start up your power transformer. In most of cases, let's say before maybe 10 years or something, when this modern demagnetization process have not been available in the market, most of the engineers have accepted that, like, usual phenomenon, and when they experience high rush current, they will just start up transformer again and again, and finally transformer will be start up. So what does it mean high amplitude of inrush current when we start up the transformer? Basically, it's normal to have some value of inrush current, but if we have magnetized transformer, this value will be quite high. The first thing that we will see is our protection relays could operate, because in this moment we will see very high inrush current, and they could think, we have a failure in the transformer, and they will trip off the transformer from the network. And then the problem in the field is usually that you don't have a lot of time there, and then you start thinking, what is happening, maybe transformer is there is a fault there is something, and there is analysis of that. But transformer is just magnetized. So magnetization is not any kind of failure in the transformer. It's normal, natural process in the ferromagnetic material that's happened. This high rush current, in some articles you can find that they explain that this value can harm the transformer, but basically the truth is that our power transformers are really, really robust and strong uh, stuff. And basically this high inrush current in most of cases will not damage the transformer. But during the repeating of inrush current, it can influence stability in the transformer. Uh, the bigger problem is incorrect operation of protective relays, because you cannot start up transformer and then you need to repeat the startup process until it's successful. Otherwise, I saw in the field that some protection engineer will adapt protection relays just to skip a few periods of the inrush current. Let's say it's a 50 hertz or 60 hertz current, and they will just skip a few periods, and then they will start continue the current. And in that case, they will just skip this issue with the high amplitude of inrush current. Basically, those relays are usually set to 2 or 3 cycles, to skip 2 or 3 cycles. But in the field, we have experienced that inrush current can durate even longer than 2 or 3 periods. And the third influence, maybe in my opinion, the most important for the testing engineers, it's a very, very high influence of the results on the results of some routine tests, let's say in that way. Frequency response analyze test, FRA test, and excitation current measurement test. Also magnetic balance test, because I see here that there are people from India, they use magnetic balance test quite often there. If your transformer is magnetized, it will significantly influence your results. Basically, you will get totally wrong results. The worst thing that can happen, that you make a fake conclusion according to the fake results, because you can have absolutely normal and good condition transformer, and you can get absolutely wrong results, and you can make absolutely wrong decision about your transformer. And in reality, this decision is very expensive, because it can cost hundreds, thousands of dollars. Just decision the transformer is not in good condition. So we need to be very careful with this stuff. Because of all of those things, it's very, very, very recommended to perform a demagnetization process before frequency response analyze test and excitation current test. Of course, also magnetic balance test. I remember one case when a new transformer has been transported between the factory and the substation. And in that case, it's normal procedure to perform commissioning testing. It's important to check that during transportation, which is very uh, tricky job, that there is no any kind of mechanical stress or damage in the transformer that can be fatal for the substation or transformer. Uh, One of very good test for inspection of mechanical problems in the transformer is frequency response analyze test. And basically, when transformer is tested during commissioning testing, frequency response analyze test have been show not good results. Even transformer has not been in operation, it has been demagnetized in the factory. Everything we have is basically the time between the factory and the substation. And there are some of our experimental results, and there is available technical papers on that topic where we have explore and analyze that transformer can become magnetized, little bit magnetized, even if it is not in the operation. So basically, the normal condition, the natural condition of the magnetic core is to be a little bit magnetized. And in that paper, you can find that conclusion was that before frequency response analyze test and excitation current test, it is highly recommended to perform demagnetization. Only in that case, we can be sure that we have a same reference conditions and we can compare results. This is one interesting example from Ethiopia. Basically, I told you it's normal to have inrush current when you start up transformer, especially if it is magnetized. And usually it happens in one or two cycles, but in that case, it happened even after 5 cycles. So it was quite long duration of inrush current. And basically in this commissioning testing, and it was a lot of issue with the conclusion what is happening, because each time when they start up transformer, protection relays operate. So everything was fine with that transformer, just it was necessary to perform demagnetization. You can also find many investigation on that topic, especially in the secret working groups or IEEE working groups, where they have analyzed hundreds of cases and transformers and basically present us the statistical behavior of the phenomenon of magnetization. So in those conclusions, we have found that inrush current, when you start up your transformer, can be decreased even 60% when transformer is demagnetized. This is the reference where you can find those details. It was IEEE working group. So I told you one example when transformer can become magnetized if it is even offline and it's just staying in the field. So here I will also show you what else can cause transformer magnetization. Uh, Transformer is inductive object, right? What does it mean, inductive object? It means that voltage and current are not in the phase. You know, the current delay behind the voltage, right? What does it mean? When we disconnect transformer, when we shut down transformer from the network, it always must be in the zero of current. Otherwise, we cannot break the current circuit. But when we have a zero current, it means that we don't have a zero voltage, right? So this difference can create uh, remnant flux that can influence the transformer magnetization. So it can be a little bit magnetized even if you just disconnect transformer from the network. Then if you have a faulty current, some kind of failure in the network, very high current, faulty current will happen in the network. This faulty current usually those faulty currents usually have a DC component in its signal in the current, and this DC component of the current will magnetize your transformer. So when transformer is disconnected from by protection because of the failure in the network, you can expect that you have a magnetized transformer. And the most important thing and most dominant thing here is DC current. Basically, we use DC current when we perform routine testing like winding resistance testing in the field, or on-load tap changer DV testing, or some other test. So in that case, we will basically magnetize transformer, let's say, close to 100%. And after those testing, it's almost necessary to perform demagnetization. So we have had opportunity to meet what is magnetization, what causes magnetization of the transformer, why the magnetization process is important, and now uh, we need to meet how can we demagnetize transformer. Very good example of real demagnetization process is demagnetization of current transformers, of instrument transformers, right? Why? Because they have a very small core, which means that they don't need a huge energy for that process. And the process is very simple there. Basically, everything we can do there is use nominal frequency voltage, AC voltage, 50 or 60 hertz, and we will increase that voltage until core saturation, and then we will decrease that voltage down to the zero. And basically, in that case, we will demagnetize our transformer. Same process can be performed for power transformer, right? So can you assume what can be issue with the power transformer? Why we should not, or we cannot use AC signal, AC voltage there? Because of energy. Because of energy. Power transformer are really huge, and they require huge energy to magnetize itself and demagnetize itself and to saturate the core, especially with the AC voltage. If we want to use AC voltage, and if we want to saturate the core, we need to use the voltage higher than nominal voltage to be able to create enough current that will saturate the core. So basically, in the field, it's not possible to make it. So we would need even additional substation to perform the demagnetization process, which is not practical. However, 2009, I think, DV Power has introduced quite innovative demagnetization method in the market, and I think that we have been first that we have used that approach in the market, which make our life much easier. So basically, the trick is in creating enough magnetic flux. So if we create enough flux, we will be able to saturate and desaturate, let's say, the magnetic core. So instead of the 50 hertz, we have decided to use DC current, DC voltage. Why? Uh, because basically, if we want to produce the flux, we can increase voltage or we can decrease the frequency. So in the same in the both way in the both ways we will create high amount of the flux. So basically, if we use DC current, we have almost zero frequency, which means a huge amount of the flux, and this enable basically uh, us to perform the magnetization process by using DC voltage, very low DC voltage, and that we are able to demagnetize even the biggest transformer in the world. So we use 60 volts DC volts for the magnetization process, and we have successfully performed the magnetization. I can really say for all kind of the transformers in the world, from very small transformer, few kilowatts, up to more than thousand and hundred MVA transformers. So with the same process, we have successfully performed the magnetization. Basically, we use DC voltage, and we change polarity, plus minus, and in that way we change the current direction. So we change the polarity and we decrease the current in each step, and basically in that way we demagnetize the transformer. This is one demagnetization process recorded with our device. So basically, I told you, we use DC current and the voltage, and then this current is charged in some value, and then this charge, and then it goes in opposite way. So change polarity, and then again change polarity, change polarity, change polarity, change polarity, and in each step we will decrease the value of this current. Uh, Basically, what is happening here, when we decrease the current in each step and change polarity in each step, we are decreasing the surface of the hysteresis loop of our transformer, bringing remnant flux down to the zero, close to the zero, let's say. So basically, why and when we should perform demagnetization, I think that even now you can make conclusion about this question regarding the previously presented theory. Basically, it is very recommended to perform the magnetization process before AC tests, such as frequency response analyze test, excitation current test, magnetic balance test. Then, very important is performing the magnetization process when we want a back transformer in the service, when we want to turn on the transformer, let's say put in the service to avoid high rush current. Uh, and of course, if we have some, let's say, wrong results and we need to make deeper investigation what caused the problem, we will demagnetize transformer and see if not normal results have been caused because of remnant flux in the transformer. And here you will also find one answer on the question you may have, because previously it was always recommended to perform AC testing before and DC testing as last test. Why? Because when we use DC test, we will magnetize the core and we will affect AC. Today, when we have a really modern devices and demagnetization approach with only, let's say, 10 kilos in the device, and when we need only 5 minutes for the magnetization process, basically we can perform DC tests, winding resistance, DV test, dynamic resistance for on-load tap changers, and then we can perform the magnetization process and prepare our transformer for AC testing and have always good reference condition of the transformer. Even if we perform AC testing first, which is recommended in some quite old literature, basically we cannot be 100% sure if transformer is fully demagnetized. Remember the story when we disconnect transformer with the network, what can happen if it was kind of faulty current in the transformer, if transformer have been offline in some period. So all those stuff can influence magnetization process in the transformer. So the best practice today is to perform DC testing, winding resistance, on-load tap changer testing, then perform demagnetization process, make very good and stable reference conditions, and then perform AC testing. Um, there are also many questions regarding the magnetization process that people in the field can ask and sometimes can be confused. One of them is what is recommended starting demagnetization current? As you could see on the previous graph, we use some starting demagnetization current, and then we decrease that current in each step until 5 milliamps is reached. Again, if you read in many of articles today, older articles, let's say in that way, they recommend to use starting demagnetization current same as used for winding resistance test, 10, 15 amps or something like that. We have performed many experimental testing and investigation testing regarding that topics, and the conclusion is a little bit different from that opinion. Basically, when we use a DC current, it is enough to use high current, enough current to saturate magnetic core. Because this is a DC current, this current can be very, very low. Basically, even big transformers can be successfully demagnetized with 5 amps, let's say, in that way. It's not necessary to use 20 amps or something like that. Um, so, not necessary to use the same current as you have used for winding resistance test. You can use a lower current and you will have the same results. Then we have a question, is that better to perform the magnetization process from high voltage side or from low voltage transformer side? Basically, on high voltage transformer side, we have a higher number of turns, right? So when we have higher number of turns, we are able to to generate higher magnetomotive force there. This magnetomotive force will, affect our magnetic dipoles to orientate in direction we want, and we will perform the magnetization process. So in that case, it means that even we have a lower current, we can perform the magnetization from high voltage side. If we go to the low voltage side, then we have a lower number of the turns, winding turns, which means that we need a higher current, right? So fortunately, the power has a let's say, very high test current up to 60 amps. So the process can be performed both from high voltage or low voltage side. If you use the magnetization process from low voltage side, our recommendation is to use higher test current. Do I have to perform the magnetization process from all three phases? Again, if you read the many articles, older articles, there is discussion that uh, if we demagnetize even middle transformer leg, middle phase, it is sufficient. Why? Because our magnetic core is, connected together. It's one piece. All three legs are connected each other. So when we demagnetize one transformer leg, the magnetic flux will flow throughout all three legs. It will fluctuate throughout magnetic way. And in that way, we can demagnetize transformer. It is basically partially true. Why? Because we also have a lot of results regarding that topics. Those results confirm that it is better to perform the magnetization process for all three phases, for all three transformer legs. Why? Because we don't know which leg is magnetized more than other. So in some cases, when one leg, for example, leg of phase A, first leg, is magnetized much more than phase C, it means that the magnetization process of middle phase will not give us very, very good results that we expect. So our procedure and recommendation is to perform all three phases, and in that case, we will be 100% sure that the magnetization process is successful. Uh, Important notification, important note here is that demagnetization is not test. You don't need to test, you don't need to obtain some results and the stuff. This is just the process that you want to demagnetize transformer and prepare for something, for putting transformer in the service or before the testing and the stuff. However, DV power devices will perform demagnetization, will give you the graph of the magnetization process, and our DEM60R model will give you also the result. What is result? Result is remnant flux before and after the magnetization process. So basically you can see that the remnant flux is decreased from some value to some value, and also you will see the percentage of that value. If you analyze DV power devices, basically you will find the magnetization feature in all of our DC test devices, let's say. Any device that measures binding resistance of the transformer, it has inbuilt demagnetization feature, including single-phase models and three-phase models. So we have single-phase devices and three-phase devices as well. The magnetization process is really, really simple. Everything you need is connect transformer phases, transformer bushings to the device. You will select the starting test current and press start. Nothing else. The device will perform the magnetization and give you the message the magnetization is done. And that is all basically I would like to present in this seminar, in this basically webinar. Now I'm going to go in the field where I can find the questions. We have many questions here, so I'm going to give you the answer on some questions here. Good afternoon. Good afternoon. That was not the question. Yes, I am going to share the PDF presentation with you. Also, if you have any other questions, discussion, you can contact us directly, or you can contact us via LinkedIn or whatever is convenient to you. This is one interesting question. Can you speak about your experience performing DC winding test on large 5-core power transformers? What methods are there for reducing time required to charge winding when applying DC voltage test? So this is an interesting question because, when we are talking about power transformer and magnetic core, we will find very different designs in the field. So one of commonly used design is 3 legs magnetic core. However, you will find also 5 legs transformers, uh, different shell types and the different construction and so on. So yes, we have performed the magnetization process for all those transformers, and in 5 legs transformers, basically we had same questions as you had. Is there any kind of difference if we perform demagnetization on 5 legs or 3 legs? We expected that we will have a kind of difference there, but all our results and the testing have showed that basically there is no such a big difference. The demagnetization process is absolutely the same. Even results are absolutely the same. Everything you need is just a little bit more energy. But what does it mean? You will not use 2 amps, you will use 5 or 10 amps demagnetization process, which is not a big difference for demagnetization process. What was also interesting for me, it was excitation current results. Because normally when we have a demagnetized transformer, we expect that we will have a outside phases should be the same value, and the middle phase will be the lower value compared to outside phases. And it means that our transformer is demagnetized and it has symmetrical, let's say, distribution of the remnant flux there. And we have expected that it will be a little bit change in the 5 legs transformer, because we have additional path for magnetic flux, but basically we had the same results as here. So even in the 5 legs transformers, we will expect that we will have a same excitation currents in outside phases and lower current in the middle phase. There is also one question. After the demagnetization process, if remnant flux does not come to 0%, does it mean that we have to repeat the demagnetization process again? And is that safe if we put the transformer in the service? This is also interesting question. Basically, I would like to mention that before 10 years, even in the soon history, let's say in that way, almost all engineers have not performed demagnetization at all, which can mean 100% of remnant flux there. And I have explained you what effect you can have if you don't demagnetize transformer. So my answer is it is really not necessary to get 0% of remnant flux. It's enough to go less than, let's say, 10% or something like that. But in most of our process, you will get very, very low value of remnant flux, let's say 1 or few percent. Maybe it can be important for current transformers, for instrument transformer, but even there, it's not 0%. There is a kind of the tolerance, maybe 5-10% that it's really acceptable. Because when you start up your transformer in the network, after few cycles, transformer will be normally demagnetized because of the AC current with high energy there. So it will demagnetize transformer. So the answer is it's not important to get down to the 0% of remnant flux. So basically, this is all for today. I told you if you have any questions, if you want to discuss some topic deeply, you can always contact us. And if you want those presentations, but also if you want technical articles we have published on this topic, I can share with you. So thank you very much for this session, and I hope we will meet next time. Thank you. Bye.